Hello, everyone, and welcome to the Ask the Expert webinar, Credit Risk Decisioning Using Intelligent Decisioning on SAS Viya. My name is Tiago de Souza, and I will serve as your moderator for today's event. Now, I would like to take a moment to introduce our presenters. First is Carla Bustani. She's a Senior Solutions Advisor here at SAS, specifically a Senior Risk and Decisioning Solutions Advisor with 16 years of experience in risk management and consulting within the financial services industry. Also on the call is Carl Eastwood, a credit origination solution lead here at SAS. Carl spent his career in credit risk, fraud, and financial crimes, working in the UK, Australia, and New Zealand. Originally working with banking and telecommunications, he joined SAS in 2016. With all of that out of the way, why don't we turn things over to our presenters so we can get started? Carl, please take it away.
Thanks, Tiago, and thanks everyone for joining today. We really appreciate you taking time out of your day to come and listen to us talk about credit risk decisioning using intelligent decisioning on SAS Viya. So just to take you through the agenda for today, I'm going to cover off just a few slides to take you through what intelligent decisioning is, the credit risk decisioning use cases that can be covered by intelligent decisioning, the credit risk decision strategy lifecycle, so just taking you up to a helicopter view in order to set up what we will take you through today. I'll then hand over to Carla to take you through a demo, and we'll talk about some of those demo activities as we go through the slides. And then finally, after a quick wrap up, we will also have time for Q&A at the end, hopefully as well. So please post those questions during the course of the demo and the presentation. So what is intelligent decisioning? So for those, I think it was somewhere around 40% of your users who've never heard of it, intelligent decisioning allows users to automate decisions at scale to drive faster and more accurate decisions, whether that's real-time, API driven, or whether that's in batch, using an ATL or some kind of batch driven triggered process. Three of the key value propositions of intelligent decisioning is it's a low-code, no-code, drag and drop user interface. So really focus on ease of use, but still appealing to those more complex coding and data science use cases if required. It has full integration with the SAS Viya analytics lifecycle. So what we mean by that is those data preparation, data quality, data management capabilities, the exploration and visualization of data, and then critically the building and development of models is fully integrated into that decision process wherever you need it. And finally, it empowers business users to reduce time to market. So how do we remove friction within that strategy deployment process, where possible, removing IT altogether, but providing a governance layer to ensure that decisions are fully governed, accurate, and not deployed into production when they shouldn't be. So what are some of the credit risk decisioning use cases that we can cover within intelligent decisioning? So broadly, we split it into two different areas. We have the originations process, so the assessment of affordability, the assessment of credit worthiness that we undertake when we onboard a new customer or even an existing customer applying for new credit to a particular loan or a credit card or a finance product, and then also the management of that credit worthiness and credit risk throughout the life cycle of that customer and that account. And then that covers many different industries, but broadly speaking, they fall into the same two categories, whether that's banking, captive finance, telecom or government, or even wider than that into energy and utilities. So today the focus is going to be on the credit origination process. We are going to use a banking example, but in reality, all of what you will see in terms of the features are agnostic and holistic across the different industries and use cases that you see on the screen here. So taking it up one level, the credit risk decision strategy lifecycle is a kind of ever-evolving process. Right? We have, right from inception, data preparation, which feeds into model development, strategy development, strategy deployment into a real-time or batch-based process, and then finally performance monitoring. Now, after that, the cycle begins again. We look to improve our strategies, or product changes or particular circumstances forces us to change those strategies for one reason or another. Today, we're going to focus purely on the strategy development and strategy deployment side of things. And actually, specifically, we're going to focus on 5 different areas, which are either new features or newer features within intelligent decisioning, or existing features that we believe can be used in slightly different ways that we might provide some thought leadership on. So the A/B tests, the advanced lists, segmentation trees, and the deployment process are pretty new features within intelligent decisioning within the last year or so. And then scoring and testing has been around for a long time, but we'd like to show you ways that you can evolve that and use slightly more automated processes to drill into the scoring data in order to test and monitor those strategies a bit more effectively. Okay, without further ado, I'm going to hand over to Carla for the demonstration.
Thank you, Carl. Hello, everyone. So let's see more what SAS Intelligent Decisioning is about and explore those features that Carl has just mentioned. I'll start with the demo. All right. So first, I'd like to give an overview of the Viya platform. The Viya platform is a web interface where you could connect your data sources, manage your ETL processes, build variables out of existing variables, perform variable engineering, build models and compare them, register those models into a model repository, get them ready for deployment, deploy those models within decisioning strategies, automate your decisioning strategies, and perform ongoing model monitoring. So all of this would exist on the same Viya platform, including at any point in time where you have data, whether it's raw data, it's processed data, transformed data, you can always explore and visualize it through building dashboards through simple drag and drop capabilities. Today, our focus is on SAS Intelligent Decisioning. This decisioning tool will help us build decisioning strategies such as the credit risk decisioning strategies that Carl has mentioned, credit originations, portfolio management, collections management strategies. The whole logic will be built in this place. The decision will be deployed in production, whether for batch or real-time processing. There's different objects that we can use for building them. We could use, let's say, data query nodes for reading data from databases and writing back into databases. We can embed a decision, a smaller decision within a main decision. We can embed code files, SAS code files, Python code, models, SAS or open source. We can embed rule sets, segmentation trees, A/B tests. We're going to see some of those today during the session. So all those nodes would work together to generate a final output. And the purpose behind today's session is really to see how we can leverage some of those functionalities for more operationally efficient strategies that really ensure customer retention, they ensure optimal revenue, and good risk-based decisions. I will start. So as Carl mentioned, it's going to be a credit onboarding strategy that we're going to go through today as an example to show how those features can be leveraged. Within that strategy, we will perform pre-bureau knockouts such as basic policy knockouts if the customer's age is under 18, let's say, if the customer's ages, if the customer has been employed for less than 2 years, we're going to reject them. Identity verification is going to be made to ensure it's a human. We go within that strategy into device intelligence, demographic intelligence. We'll perform credit risk assessment process, which is the main focus today. We're going to go deeper into that process. And then the strategy in itself also performs fraud identification, credit risk, customer risk assessment in terms of sanction screening, customer due diligence, and provide a final decision. So within that same decision engine, we're sort of generating a holistic decision on an application process, looking at all the different dimensions: fraud, AML, credit risk. Today's focus will be mainly on the credit risk part. So I will go deeper into that node, and we'll explore some of the main features within that node that we're leveraging within that node. An overview on what we're doing here. In this process, we are performing income verification. So the customer has declared their income. We're benchmarking that income and trying to see if we are confident about it, whether we need to do some manual verification or not. Then we bring in bureau information into the process, verify, check the indebtedness of our customer, segment our customer from a risk-based aspect, then do risk-based pricing to determine the optimal price for that application, loan application, then determine the limit that we are to give for that specific request, and finally grant a credit decision with explanation on why we're giving that decision. Let's go into the income verification piece. Automating income verification is important for one reason, because we want to speed up the process. We want to grant a decision quickly. We don't want our customers to wait long before a decision is to be granted, unless there's really a need to manually verify the income of our customer and contact, let's say, the workplace. In some cases, or in a large portion of cases, income verification can be automated, whether through the use of predictive analytics or income estimation models, or through the use of API calls being made to third-party sources to verify the income on the fly within the decision strategy itself. So in this case, we are leveraging those two functionalities. We are first making use of our data. We have historical data of our customers. We know their income. We can make use of this rich data that we have and build income estimator models and simply embed those models within our income verification strategy, compare the declared income versus the estimated income. And if this is, if they're comparable, or if this makes us more confident around the declared income, we can feel comfortable about it and proceed with the application process. Otherwise, we can make an API call, let's say, to a third-party data source and bring in this information. Another important aspect here is to make sure we control for all the API calls we are making to third-party data sources, because every call is costs us money. Throughout the process, we are making API calls for identity verification to the credit bureau, for, let's say, open banking or other income source. And every call is costly, so it's important to design the decisions in a cost-efficient way so that those calls are made when necessary, when our internal data and predictive analytics does not really support or is not really able to verify the income or what we're trying to verify. So cost optimization is essential when building decisions, and we've seen customers really lower or optimize their costs efficiently through that process. The second aspect is to go into bringing in the credit bureau information. Through connecting to the credit bureau, we derive the debt coverage and see other metrics that we would need in order to be confident around the credit status of our customer. And then we will use what is the feature that is the A/B test functionality within SAS Intelligent Decisioning. So among the different objects that we have in SAS Intelligent Decisioning is an A/B test. It is a feature that allows us to test a champion model versus a challenger model, to test a champion rule versus a test rule, or a strategy, an entire strategy versus another. This helps us test the challenger strategy in production against the production data. It helps us maybe benchmark or be more confident around our champion strategy or model, or maybe test a new strategy on a small percentage of a population. For example, here we're testing it around against 20% of our population before we can deploy it fully into production. In this example, we have an internal scorecard for determining the probability of default of our customer or for scoring our customer. We have added the scorecard, which is based on a simple logistic regression to the champion path as a model, whereas we have added as a challenger strategy the gradient boosting model as a challenger option. To pick up a model is pretty simple. We can go into the model repository, where we go to the model project and pick up a model, whether it's a SAS model or an open source model. We choose the version that we need and pick up the model right into the decision, without worrying about the underlying score code or underlying files. As a decision builder, strategy builder, I don't really want to worry about the models built, let's say, by the data science team. I only want to focus on embedding the model into my decisioning strategy. And now that I have it in there, I can just leverage its output, which is the probability of default or the score itself, in order to determine what is the risk segment of my customers. Just another point, when building A/B tests, we can also use them, let's say, in collection strategies. Let's say I have, when building my collection strategy, I have rules on what is the next best action for my customers, to contact my customers. If my customer was, if I have contacted my customer via an SMS, my customer did not respond, then the next best action is to call them. As a challenger option, I can try and test, what if I can include predictive models that would help me determine what the next best action is? And see, with the use of predictive analytics running against, say, a small percentage of my population, is that percentage performing better or is helping me collect better than a rule-based process? So that's another example of using A/B tests for another risk use case, such as collections. So now that I have determined the risk segment and the probability of default, I can then use this information for risk-based pricing. So instead of determining a standard price, and we see it's always difficult to update the latest price parameters when pricing customers in real time, SAS has a nice feature that allows taking in always the most recent price metrics without having to touch the decision itself. I will go back. So this is a risk-based pricing calculator. It's pretty simple. This is just a simple example. I have gone back to version 1 of this rule set. And in here you see down below is the formula for calculating the risk-based price. I'm using the hurdle rate, the capital required, cost of funds, return on savings, and the probability of default and loss given default. As inputs, I have hard-coded those inputs in that rule. Once the decision goes through that rule, it will help calculate the interest rate. What if I don't want those to be hard-coded? when the decision is in production. And I want a more dynamic way of defining those parameters, those numbers, and updating them as time goes by. I will go to version 4 of my rule. And here I am. I am looking at a lookup table. So now I have a multi-key lookup table where I am bringing in those parameters from that table. And now I have sort of decoupled those parameters from the decision itself. And as always, I'm calculating using the same formula, the interest rate that is to be generated. What is that feature behind that lookup table? We have the advanced lists functionality in SAS Intelligent Decisioning. So here is my table where for each product and customer tier, so you see here I'm also embedding some marketing analytics in there. For each product and customer tier, which are my key columns, I am bringing in those parameters to sort of customize the way I am charging customers based on, let's say, our historical relationship, based on the product that is being granted, and of course, in the formula based on the probability of default. So my rule is simply picking up those values. Once my decision is in production, I can always update those values, making sure the latest are being taken by the decision itself and the customers being priced on the latest metrics. To create that table is pretty simple. I just upload a CSV file, or I could even do that through the user interface by just adding the necessary parameters. Another way of also using this for collections, when building a collection strategy, if I have so many if-then rules on, again, next best action, I can embed those rules in an advanced list with the key, let's say, being the previous action, customer's reaction, and then the parameters that I'm looking up are what is the next best action, and let's say days for this action to happen, how many days to remain compliant with consumer protection regulations. So it sort of helps me, this feature really helps me be more dynamic and build my rules in an easy and efficient way instead of having to write so many if-then rules, or in cases where I need to update my parameters on the fly. So let's go back to our decision. Here is my rule set. I calculated the price. I can add some more conditions on top of that, probably some industry risk adjustment factors and so on, and generate the final price for this application. Now it's time to determine what should be the limit that I am to give to my customer. I do not want to go for a one-size-fits-all strategy. I want to sort of customize the way I give limits or I calculate the limits for my customers. A retiree with investment properties, let's say, or some large investments would be treated differently from, let's say, an employee with an employee in a high-risk industry, or an entrepreneur who has big business in a low-risk industry. So I want to be able to route my customers across different limit strategies. And I want to follow a deep layered segmentation process that is really built on simple rules, but there's just so many layers that I'm going to be using. For this purpose, I'm going to use what we call segmentation trees functionality. So what are segmentation trees? Segmentation trees are really decision trees that could have very, very deep layers based on simple logic. Yes, no values for a specific variable, different values for a specific variable, a matrix, which is a combination of two variables that will also generate a list of branches. And then I will have an outcome at the end for each of those branches. So In this case, for my limit strategy, I'm looking at whether this is an existing client, yes or no. If this is an existing client, I'll look at their industry risk. If it's a medium or low industry risk, I'll look at the employment status. If the customer is self-employed, employed, or retired, I'll have a specific limit policy for them. So I will be able to identify if this is, let's say, a standard entrepreneur or an employed customer with a salary or a retiree. And if this is a low industry risk, I will look at their employment status versus their risk, because I want to be able to identify who are my gold entrepreneur customers, who are my gold employee customers, and then the rest would probably be more standard or follow the standard limit policy. I'd like to show you a bit how this functionality works, or how we can build a segmentation tree. I will create a new version of my tree. So now I have that same tree. I'll just delete the nodes and keep only the first one. All right. So now I have, is this an existing client? Yes or no? I have my list of other variables such as industry risk in here. I have attached the values to those variables, and now I can simply drag them and drop them into the tree, adding them as branches. And let's say now I would like to look at the employment status for the medium and the high. And for the low industry, I'd like to embed a matrix that takes into consideration two things: employment status and the risk segment. And here I have a matrix. I have already defined the matrix. In that matrix, I'm sort of identifying or differentiating between self-employed and employed retired versus risk segment. And for low risk self-employed customers, I have labeled them as gold entrepreneurs. Others, I have also labeled them based on how risky and what their employment status. So I can simply also drag this matrix to the low risk customers. And then for each and every final node, I can really embed for the final outcome. For a gold salaried customer, I can add, let's say, preferential salaried limit policy. I have already created those outcomes in here, and I can simply just add them in order to simply add them through just selecting them as an outcome. So this is how easy it is to really build our segmentation trees. We've seen customers build really complex trees, especially when it comes, let's say, to collections, where they would need to embed the logic behind the next best action through a large number of rules based on customer characteristics and days past due and so on. So all of this can really be done through simple drag and drop of variables inside the segmentation tree, creating really deep layered segmentation, customer segmentation. Now that I have defined the segmentation, I use a simple branch in order to drive my customers across all those different outputs and all the different limit policies that I have for each and every output. I am done with that now. So I have done my income verification, done the risk assessment of my customer, determined the limit, the pricing, and now it's time to generate the final decision from a credit risk aspect. So here I am just looking at the final decision, also embedding rules on conditions based on the customer's risk profile. And one interesting features that customers are using a lot is to leverage the treatment group functionality for explainability and transparency. So within this functionality, I have embedded sort of my reason code stock in here. So all the different reasons for a decision to be rejected from a credit risk aspect. And behind each and every reason, I have eligibility criteria. So for that reason to be triggered and to show as a final decision, as a reason for the final decision, I have eligibility criteria behind the scenes. So I click on one. This is the reason code. This is the decline. And those are the eligibility criteria that will help trigger whether this reason will show up for a specific application or not. So this functionality is easy to use and helps, instead of building so many if-then rules within a rule set, helps you manage your decision, your reason codes all in one place for two reasons, either for testing your decision. So whenever your decisioning strategy, you built your decisioning strategy and now it's time to test it on a historical data set, it's important to know why a certain number of applications are being rejected and how can you maybe change the rules and the conditions in a way that you do not reject as many customers, instead embed additional conditions and guarantees and requirements, or in order to approve the application, but yet at the same time mitigate any risks involved. On the other hand, once the decision is in production, those reasons will really help you explain to the client the decisions for the decision being taken. So I have generated the final decision. I have used champion challenger testing. I have used the advanced list functionality for more dynamic rules. I have used the segmentation tree to be more, to build, not to build one size fits all strategies, but to use a lot of segmentation and customized customer treatment. And I have used treatment for sort of defining all the reason codes. Now let's test our strategy. So here I am. I can go to the scoring tab where I can run a test against a historical data set, or I can run scenario tests against a specific scenario or multiple scenarios, and then compare the results of multiple scenarios to see how my decisioning strategy is really working. In this example, I have run a test against a historical data set. I choose the version against which I am running the test, and I can see the results. And I can see how the applications are being treated by the decision. I can run a rule-fired analysis for each and every record and see all the rules triggered for that record. It helps me understand for specific records why such a decision is being granted. And then I can do a path tracking for my decision in a way that I could really see what percentage of applications are going through the decision flow. I could see, for example, here, I have a certain percentage going through all those limit policies, but I have a large percentage going through the other branch, which does not really, which is not really what I expected. I would have wanted, let's say, a lot more to go through the standard entrepreneur and the standard salaried limit policy. And this helps me go back and try to understand what is the reason for directing all those applications towards the other limit policy in order to better understand, to better fix my strategy before I deploy it into production. So I'll go back to the output of my test now. And I'll go to explore and visualize. So as mentioned, every time I have a data set within the SAS Viya platform, I can always explore and visualize this data set. What does that mean? I can always build reports within that same web interface and try to understand all the underlying relationships within my variables. And those reports, once built, whenever I update that table, they're always going to update accordingly. So if I run a test against a certain historical data set, I save the test, or I save the data set, the output data set, and then I fix something in my decision and then run the test again, I can always see how visually the distributions change within my report. I'll show you a quick example on how I could use that report. For example, now I took my output result into visual analytics to explore and visualize. I will, let's say, for example, build a histogram. I want to see the distribution of my scorecard points. I can see them easily here. I will build, let's say, a pie chart. Sorry. I drag and drop, and let's say I want to see the distribution of the employment status, for example. Or I could even see the distribution of the final decision, what percentage are being approved, what percentage are being rejected, and what percentage are being referred, for instance. So once I save this dashboard, I'm always then able to go back and see the changes on my dashboard every time I rerun the test. I would like to show you a more detailed dashboard that could be built. Let's say I am the decision, I am now validating the decision, and I would like to see how the decision is really impacting my historical data before I go into production. I have created this dashboard. I am looking at, let's say, data quality checks. What percentage of applications are requiring, let's say, data quality checks? What percentage are requiring or are generating either a red no rejection decision or a referral decision, and also for conditions. I can go deeper into the reasons for the decision being taken. I can see which have the highest number of applications being rejected, or which reasons are generating the highest number of rejections. And this will really help me understand if my strategy is working as expected, if I can do anything to maybe accept those, but provide counter offers, provide other conditions to improve the decision being taken. I can also go deeper into each and every application and analyze those red and yellow applications more, and do further checks to verify the decisions being granted. So I can build all those dashboards myself, make sure they're continuously up to date based on the latest test data, and also at the same time compare them to the decision in production. So I can connect to any data source, make sure I have the right reports that will help me stay in control of my decisioning strategies and know when I need to make changes to them in order due to changes in the market, due to changes in customer behavior, and so on. All right. So I built my decision. I am now confident about the decision itself. And I'm sorry, I'll just go back to that screen. And now I would like to publish the decision. So I can hit the publish button. And I'll be able to publish the decision for real time or batch. Being an onboarding decision, I would probably want to publish it for real-time processing. So in this case, I am publishing my decision. I could publish it to a container or to SAS's micro analytics service or for real-time decisioning. If it were a batch decision, such as the case of collections, I can always publish the decision to SAS's Cloud Analytics Service, for instance, where I can really embed the decision within a whole flow, a SAS Studio flow that allows me to prepare my data, run my decision, generate the output, and know what next to do with each and every customer that's that is currently delinquent. So this is for the collections process. I can always view the history of published decisions. Sorry, I'll go back to here. This is a decision that has been published already. I can view the history of all the times I have published the decision. I have now the ability to make an API call to it and just embed it, integrate it within my ecosystem, the IT ecosystem of the institution, where I could really automate now the process, the onboarding process. All right, so one more thing around decisioning, and that is when building decisions, sometimes there's a need to orchestrate the decision building process. So we have a business analyst. The business analyst is really building the decision, analyzing the underlying rules, understanding the different functions. We have different teams collaborating, fraud, credit risk, marketing teams, all collaborating towards building this onboarding strategy. When building a decision, there's always the ability to sort of manage the tasks through SAS's workflow capability, to manage the tasks between the business analyst who's building the decision, the validator, the decision validator who's gonna take that decision, test it, run tests against it, compare versions, analyze the documentation, perform visual analytics to understand its impact on metrics. So all of these are really, this work has to be coordinated across the different teams. And finally, there's the decision deployer who's going to really make sure the decision gets deployed into the right repository, or the right using the right tool, or to the right container, for example. So all of these tasks have to be coordinated, and there's always the ability to sort of orchestrate those tasks using SAS's workflow manager, where you could build custom workflows and embed them, attach them to those decisions, allowing you to orchestrate this process. So this is basically what we're trying to show. What we have tried to show here is how you could build operationally efficient strategies, how you could build them in a more dynamic way to make sure you are really personalizing the decisions, personalizing the relationship and the communication with your clients, and making sure your decisions are easy to adapt to changing market conditions. And the fact that this is low code, no code tool helps you change the decision itself, but at the same time embed rules that are decoupled from the decision and be able to change the rules outside the decision, rather than having to touch it every time and having to redeploy it into production. So I'll leave it now to you, Carl, to proceed.
Yeah, thanks, Carla. It was a brilliant demo, and hopefully that's given you a little bit of insight as to how you can use SAS Intelligent Decisioning for credit risk decisioning and other use cases beyond that. I'm just going to wrap up now, just take you through a few different key takeaways, and then we're going to cover some of the questions that have been asked throughout the demonstration. So SAS Intelligent Decisioning simplifies the creation and deployment of comprehensive credit risk decisioning strategies for both real-time and batch-based use cases. We have operational agility, drag and drop configuration that empowers business users to manage their strategies without the help of IT. Increasing customer engagement and retention through the use of certain objects within intelligent decisioning, such as customer segmentation, to personalize and segment different groups of customers. And then supercharging that evolution and innovation process. So how do we use champion challenger pipelines to test different scenarios and strategies? And then how do we automate the testing and monitoring process so that it fosters that ongoing feedback loop and that ongoing cycle of innovation? So thank you very much for your time today. We're going to cover a few Q&A questions just now, and Tiago, I think you're going to take that away.
Thank you. Yes, with that, we will be moving into the Q&A segment of the webinar. All right, now on to our first question here. If I make a change to some part of the decision, i.e. a rule or data variable, can I see what impact that has had on other decisions? Is there any form of lineage?
Yeah, so I'll take that, Tiago. So yes, in all areas of the decision flow, whether that's in particular objects or whether that is when you're looking at the list of variables that are available to you in a decision flow, you're able to use an option called use by or lineage. So that shows you where that object, such as a rule set or a particular data variable, is used either within the same decision flow or within other decision flows, so that if you're making a change to it, you know that it's going to impact other things.
Gotcha. Thank you. Someone else asked, can intelligent decisioning be called or integrated with external systems, such as another loan origination system or a CRM system?
Yeah, I'll take that one as well, Tiago. So we had a couple of questions like this. So I think Carla explained intelligent decisioning can be triggered either via an API call or via in a batch process, some form of ETL process, or in a scheduled job process where it is triggering an integration to pull data from a database, for example. So in the case of another loan origination system or an upstream CRM system, typically what we would expect is that would be an API call into intelligent decisioning in real time. And then within milliseconds, we are responding with a decision and a set of outcomes back to the upstream system.
Gotcha. Thank you. Another question here. Is there any way to test bulk data, not from the database, but manually designed test cases to cover all test cases that happened on production?
I can take this one, absolutely. So we have in our demo today, we have tested against a database, but I think when I mentioned the scenarios tab, this is where you could really test specific scenarios. You could test, you could either upload those scenarios via Excel, or you could input the values for a specific scenario, and then you would be able to compare, let's say, different scenarios against each other for the same decision version, for example, or for different decision versions. So you could definitely try specific scenarios because you would expect them to happen, and you haven't probably seen them in your historical data, and then see how the decision is really affecting them. And you can also trace the way the variables are being generated across the decision until you get to the final output. This helps you understand better what is happening behind the scenes.
Thank you. Someone's asking, you covered strategy testing and monitoring, but how are the models that are in the decision flows monitored?
I can also take this one. So definitely we need to monitor models because models deteriorate with time, population shift happens, and so on. So it's important to monitor them. We accept clients via, let's say, the onboarding strategy. Those clients become existing within our portfolio. They will eventually either perform as expected or they will probably default. So this feedback loop would always come back to our centralized model repository, therefore generating performance metrics and bringing out accuracy metrics, model drift, fairness in lending, and so on. So all of these will really generate that feedback loop and provide ongoing performance monitoring. Another thing with risk models is that we also have predefined KPIs for specifically risk models where regulatory reporting is important. Those predefined KPIs are there in Basel Working Paper 14, and users can also always add their own KPIs and perform ongoing monitoring and automated documentation for all of those.
Gotcha. Thank you. Another question here. Where are decisions and strategies published to?
Yeah, so Carla did cover some of that during the presentation. And in reality, what there is there's the option to publish to either a batch-based engine or a real-time engine. From a real-time perspective, we have what we call SOCR, which is SAS Container Runtime. That is an environment, a lightweight container environment where you can scale infinitely horizontally, and it doesn't actually need Viya as a piece of software in there, which makes it extremely lightweight. In terms of how that then performs, we can then manage, well upwards of 20,000 transactions or events per second, respond within milliseconds to that. Just one other thing actually on that, while there are other batch-based engines, they do require Viya as part of them. In Q3, before the end of this quarter, SAS Container Runtime will be able to be executed within a batch process too, which also then now provides that lightweight option for batch-based processing.
Thank you. Someone's asking, are there governance features to reduce strategy change risks like check-in, check-out, and version rollback?
Absolutely, I can take this one. So we have the checkout commit feature where users can actually, if they'd like to make a change to a rule or a specific object within the decision or even to the decision itself, they can just check out that object, make the change locally in their folder. Once they're confident about it, they would commit it back into the master version. This helps with auditability, traceability, and so on. And at the same time, you can do version tagging in order to help streamline the release management process. So we could tag different objects as, like, this is for the August 2025 release, for that rule, for that code, and so on. And then when release management, when release is about to happen for August, we can all merge all those changes all in one decision and deploy them into production.
Yeah, and maybe just to add to that, finally, that one of the cool features that I love in intelligent decisioning, which we didn't show, is the version comparison options. So you can either compare code or you can compare the objects side by side from one version to the next. So that kind of rolls into what Carla covered at the end in terms of governance. So you can create your own customized governance process, which might require another person to review changes. You can set them tasks, and in the release, one of the releases in the next couple of months, there'll be a task window that pops up as whether I'm a designer or a reviewer, and I can manage the various things that I might need to do. And so that might be version comparison, that might be check the scoring, the testing, that might be printing documentation to review offline with other people. So you can manage that in any way you want and customize that using Workflow Manager, and then have those tasks within intelligent decisioning showing to you.
Perfect. Thank you. On behalf of myself, Carl, and Carla, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.